Okay, we're live. We're so excited to be here today. Dru and I were just sitting backstage having too much fun that time passed so fast. We had 5 minutes and then now it's time to begin. So we're really excited. I'm here with Dru Burr, Coffey Engineer. He heads up the materials testing lab, and we're really looking forward to showing everyone around today and discussing the topic of materials testing. So Dru, how's it going over there today?
Oh, it's going well. I'm super excited. Holy mackerel. What exciting stuff it is just to be able to demonstrate live what's going on in the lab, and yeah, it's a beautiful day. And it's just super exciting too, because we for our demonstration, it's for real. We are on day 28 for our cylinder break, which is really important.
Yeah, you were saying that backstage with me. That's really cool. I thought you were just going to prepare a demonstration for us that was, just a test or a trial, but you're actually demonstrating a real test that you have to do that's 28 days ready to go.
Yep, that's right.
Awesome. So we're so excited. Well, before we get to that today, we have some other topics we're going to talk about. We're going to let everyone know what materials testing is so that they can kind of get a feel for what you do and just how important materials testing is and everything that it's involved in terms of, the construction and the world around us. But before we do that, I first just want to tell everyone tuning in that we do have a live Q&A session at the end of this live stream. So if you all want to just type in any questions or comments are welcome to into the chat box. We do have people tuning in from Facebook and LinkedIn today. Anyone can type in your messages into the chat box at any point in this live stream, and we'll either get to it as the questions roll in, if the conversation allows, or we'll save time for the very end to answer everything. And we do plan to answer everything, so feel free to type in any question or any clarification you need. That's what we're here for today. We're really excited to show everyone about materials testing, and we really want you guys to get it. So again, we encourage you to ask questions. All right, Dru, it's time I pass the mic over to you. So why don't you tell us a little bit about what materials testing is?
Yeah, sure. So, I've had the honor over 4 years to learn exactly what material testing is, and it's just been awesome to be able to just learn everything you can, at Coffey here, and so material testing, in a sense, is it's testing soil and concrete primarily, but it also involves high strength steel connection inspections, whether it's welds or bolting. And in a sense, after looking at things and the whole big picture, material testing is practical insurance for our clients, essentially. When we test compaction under soil, compaction under like a structure or a road, we ensure that the soil underneath is going to hold the load, whether it's a highway or a structure. And so when you come back, and if for whatever reason there was some problems with the road, when we have our results saying, hey, this was constructed correctly, then our client, which is a lot of times contractors, can say, look, you can see based on Coffey's records that we've done everything correctly and that we are not liable for any problems. And so, we don't operate like an insurance company in any way, but in a way we're very much practical insurance that makes sure that third party that makes sure everything's being done to spec.
Yeah, that's super fascinating to me. I love how you describe it as practical insurance. That makes a lot of sense. I mean, this really sounds like something that in a construction setting that somebody needs to test these materials and make sure they'll hold, most simply. And we just want to make sure that these materials are safe and they'll hold and they'll do what we intend for them to do. So it really makes sense that this is its own little world of construction. And I'm curious, Dru, how many construction projects that we pass every day do you think have materials testing as part of it? I mean, is almost every construction project subject to materials testing? Or, for example, as we're driving to work every day, we drive down the highway, we pass some buildings, we're on the road, we might go over an overpass. Can you kind of tell us what we would pass in a given morning that most likely had to have had materials testing in it?
Yeah. You're absolutely right. Not many people know how much goes into every project. Material testing is involved in almost any commercial project, whether it's an Amazon fulfillment center or a Walmart or a Target or a restaurant. The Rib and Chop in Laramie use material testing. The Maverick gas station use material testing, and then on top of that, any public highway, whether it's a state highway or city street, or a collector, or whatever it may be, there is massive amounts of material testing that goes into that. And it's also just interesting for me because it's kind of humbling in some ways, in the fact that civil engineering is one of the most important parts of a project, yet it's probably the least noticed, and that it's cool, honestly. I don't care to be noticed, and I know most civil engineers are pretty, they're pretty humble. They're pretty just do their job and don't really want much recognition. And but yeah, all of those projects involve soil compaction, underneath the foundation of any commercial building or restaurant. The concrete quality, we make sure it's not too wet to make sure that it's going to meet strength. Make sure it's got air in it to account for freeze thaw. That's really important in Wyoming as we get sub-freezing weather quite a bit. And if we don't have that air in the concrete, it'll crack. And that air inside the molecular level on the concrete, that allows for the entire foundation to kind of swell and shrink based on freeze thaw. And so that's really important in any project that has multiple people involved. And so yeah, and I guess also asphalt. Any asphalt project, especially for the Wyoming Department of Transportation, they require coring, and then they also require nuclear density testing as well. Every 50 to 100 feet, very stringent specs there. So.
Wow. So when you're talking about the Department of Transportation and how they require certain testing, that makes me want to ask, the other projects that you may come by, like you were mentioning before, like the Maverick gas station, or just any other building around, are materials tests required? And if so, who requires them? Or is it just, as you said earlier, that really cool phrase or term that you came up with, practical insurance? Is it just something that the client, it's just in their best interest to get, but no one's actually really making them get it?
Yeah, that's a really good question, Marissa. Back 40 years ago, or maybe it was even as close as 30 years ago, a project was done by a handshake, an agreement, like, yep, you're going to build my building, and I'll give you this money. And, I mean, there was a lot of things done with a handshake. And, you know, but nowadays, with more people, more safety concerns coming up, and just, it's natural for us to want to have more security. The more secure we are, the safer anyone feels. And so with that has come just this wave of specifications from municipalities, from cities, from states. There's and they're becoming more stringent, and so yeah, when we talk about specific specifications, there's a specification in Wyoming called the Wyoming Public Works, and so that specification lays out compaction requirements for projects within Wyoming, and especially the ones that the state's involved in. The Wyoming Department of Environment and Quality, the Wyoming DEQ, they require specific requirements, especially for on-site septic plans, and things like that. You got to have a clean out at bins, to make sure that if there was something that happened, that your septic system doesn't fail. And then of course the specs that are really important is compaction and concrete, because if those fail, your whole building could fail. And so, and then if we talk about the private side, any state or county or city has requirements, especially for commercial stuff. For residential, not as much, but even in Larimer County, they're getting more stringent. And I just found out the other day that Larimer County requires a engineer soil design report for any septic system that's on site, that's not in a going into a septic pipe to go to a treatment plant, but to just be treated like through a leach field.
Wow.
And so, yeah, that was crazy to me. That's very stringent. But yeah, with the private sector, not necessarily there's specs required, but you're starting to see that, for example, Maverick, the gas station, they're planning on building 40 gas stations just this year. And I was honored to be the material tester for one of their gas stations going in Laramie. And they've got an entire spec book for all their projects. And so you're just starting to see that that spec, it's essentially a specification is the agreement between the material tester, between the contractor and the client, saying this is how this is supposed to be done.
Wow. And so then it's up to you as the material tester to go in there and read those specifications, and then make sure that you're testing towards them.
Yeah, that's exactly right. Yep.
Are there ever any cases in which you might think that or feel that with these, as more of these spec books come out, that you sort of have to meet the requirements when you're testing? Do you ever find that sometimes your findings or what they're requiring might not be what you'd recommend?
Oh, absolutely. Yeah, absolutely. The one of the most common occurrences that I come across is with backfill, and what we have to do for making sure that they meet compaction is called a proctor. And a proctor essentially is a lab, a standard lab test that's done in a mold, so we can figure out the exact density that the soil needs to be with the correct water content. And the problem is, though, a lot of times in Laramie and a lot of places, you have rocks that there's large rock content. in the soil. Okay, and so when you have large rock content, no lab, unless it's like a huge government funded lab, can run soils with high rock content. Essentially anything 30% and over of the 3/4 inch sieve cannot be done. And so, I have to come to the client and say, hey, this is your spec, but that doesn't apply here. We have to come up with a different way. And so, most of the time we just take good pictures and we see what the contractor's methods are, or the construction crew's methods. And, once we verify the methods and say that their methods are good, that's pretty much the only thing you can do in that situation.
Wow, that's super interesting, Dru. It sounds like the world of materials testing is definitely dynamic in that, as you're saying, more companies are rolling out these spec books. And then sometimes the spec books aren't necessarily where you would recommend things to be. And then on top of that, you were mentioning earlier that, that comment about the on-site septic systems now in the area require engineer stamps. And we can actually see, it looks like one of our fellow colleagues here at Coffey says, Chase Corbridge, thanks for tuning in. He said he just heard the same: on-site septic systems now require engineer stamps. So it's really interesting. It sounds like this is definitely a very dynamic industry. And it's really great as it demonstrates here that we're on top of things and staying in tune with changing requirements, for sure. And then also having our own set of standards that we can, just use our practical knowledge to say to a client, this is what your specs are saying we need to be. This is where it's saying we need to be, but actually, we need to be here. So
yeah,
very interesting. So now, it seems like there are some obvious benefits to materials testing. As we mentioned, definitely seems like there's a durability situation, a durability benefit to materials testing. You can ensure or feel a little safer knowing that things have been tested, that the project will be able to be a durable and long-standing construction. And then it seems that, the other obvious benefit is going to be safety, right? To make sure that with the durability comes the safety. With the durability of a highway material, that it would indeed remain safe for, thousands of individuals to drive over every day, that material can withstand that pressure and that wear over time.
Yeah.
Would you say there are any other benefits that are maybe less obvious or offshoots of these benefits to materials testing, Dru?
Well, yeah, there's a couple more. I mean, as you mentioned, safety is just the number one I mean, if I see anything unsafe, I will either myself authorize a stop work, or if I don't have that authority, find someone that does.
Wow.
If soil's being installed wrong and they're not compacting, and a building foundation is going to go on there, it's huge red flags, and I will refuse to test anything until it's done right. And then durability is just so important. Buildings can settle over time. If there's any voids in the soil, any significant voids in the soil, and so those two things really important. But the other thing that sometimes I think our clients don't understand is it's saving them money. That if for whatever reason a building, a multi-story building collapses due to lack of compaction, the lawsuits that exist from that would probably bring that company completely to crumbles, you know.
Mhm.
But if there's suspect that compaction was the problem for a building that fails, and you know they have their material testing company such as us, and they say, hey, show these people that we did it right, you know.
Right.
And so we're that practical insurance that ensures safety, durability, but also saves the contractor money.
Right.
And not only that, but time, and time is money, I mean, for the most part. But time, you know, is important too, because if for whatever reason, you know, when you're building a road, if you don't have it correctly compacted, or um or there's something wrong with the material when you go to lay asphalt down or concrete, and it just cracks or breaks, you know, under that, then they have to come back and redo that. And that could be, I mean, that's tens of thousands of dollars in labor and material lost.
Yeah. So it seems like it's kind of one of those situations in which do it right the first time instead of having to continue to patch up, rehash, redo. So the financial benefit is definitely there as well. Good point, Dru. So we've got the durability being a key benefit to materials testing, the safety being a key benefit to materials testing, and then also financial savings being a key benefit. So those are three really huge savings benefits to materials testing for sure. So thanks for sharing those with us. And I think what we can move into now, Dru, is if you have any recent examples of some projects that we've done in the recent past.
Yeah, for sure. And are you going to show some pictures as well of
Yes,
those projects?
definitely.
Yeah.
I can pull a picture. So you just let me know which one you are going to
Yeah,
start.
let's talk. I'd like to talk about the Laramie Readiness Center. It had every kind of inspection and material testing there really is, to a project. And yeah, just to introduce a little bit of the project. You know, this was a huge training center for the National Guard, and yeah, that's the final photo. I got to see the bare ground, as they were clearing off the grass before anything was done there. And
Wow.
yeah, that involved tons of compaction testing, for under the foundation, and under the parking lot. Um, and then there was lots of concrete testing. Um, there was, I think I had over 120 sets of cylinders, which, so there was 120 pours that I tested on that project, which that's a lot of concrete. And yeah, as we moved to there, that's what the walls look like before they put all the nice fancy stuff, exterior finish. But that's just a cinder block, formerly called a concrete masonry unit. And with those, we would go out and inspect the rebar reinforcement. So they put grout in those cells, and so when you put grout in those, they put concrete reinforcement in there, so to help with durability, and to give the wall overall more strength. And so yeah, that was a huge part of that project. Almost the whole entire thing is CMUs, and which is good. It's good safety, you know, for our National Guard. And so yeah, we also did some fireproof. We checked the fireproof coating on some of the beams in the on the bottom floor that supports some of the top floor and the roof, just in case there was a fire. They had some wooden beams that needed fireproof coating, and so we made sure it was the right density, made sure it was the right adhesion. So that was kind of a random thing that isn't super common on projects, but that wasn't one of the last things we did on that project. And yeah, now we're happy to be a part of an important structure for the security of for national security of our country.
Absolutely. It looks like, from what you said, you guys really, it's interesting to hear all of the pieces that go into building construction. I mean, it's just a whole different world to think about, how materials testing applies. And, as you mentioned, just that fireproofing, even. These are things that, when you walk into a building, you might think a little bit more about the four walls that are surrounding you and what all went into making them stand in a safe way.
Yeah, yeah, absolutely. One other project to talk about is Premier Bone and Joint. Um, you know, uh, that project, we truly did pretty much all the material testing for that project. The other one, there was a few other contractors or other companies, but yeah, with this one, we did, again, we made sure that the soil underneath the foundation was compacted, and any trench that was filled in was compacted, and then just to make sure there was no voids in the soil. And then on top of that, we checked the rebar that went into the concrete foundation. Then after we checked the rebar, we tested all the concrete for everything going in there. And yeah, as we see some of that pictures, if you scroll up just a little bit, Marissa, yeah, that first picture, what we're doing there is called a roll proof, and so this wheel roll proof, we load a front end loader with dirt or rocks or whatever, and we have it drive on the soil, and if your soil is compacted correctly, it should pass this test. But sometimes you can have compacted soil and fail this test because there's groundwater underneath the soil, and so if there's groundwater close to the surface, or the surface just got really wet from a rainstorm, and it seeped down, there'll be cracks that are left, and depressions in the soil from the heavy load going on it. And so if that happens, we have to remove and replace that material. Otherwise, it will swell or shift under load. That parking lot could be compromised. That's under the parking lot, one of the areas of parking for the surgery center. And then, yeah, if you keep going to the next photo, they're installing roof joists and beams there. I had the honor to be certified to inspect high strength bolts and bolt connections and welds, and so I checked, all the bolts, all the bolt connections for the joist to the columns, and then the welds, made sure the welds were good quality, that the correct temperature was used for the weld, and so that holds the roof. Super important part of material testing as well.
Wow.
Yeah, do you have any other pictures, or are those the only ones?
Well, actually, Dru, that's a great point. I was wondering if we could get a before and after picture, or at least an after picture, to see what Premier Bone and Joint looked like once the structure was complete. So I'm just typing into the internet here. I'm looking at some pictures, and it looks like, I think now this structure was the old building. Is that correct, Dru?
Yep. Yeah, that's the final product. Yep.
Of the old building, right?
Yes, that's the old building. And then
Okay. And then let me see if I can get a visual of the new, maybe not on their website. Let's see if I can just go to images, see if I can find something. Isn't it more like this one now? Let's see. Here we go. Right here?
Yeah, yep. So that's the surgery center, the
And
the new surgery center and the final product.
wow.
But yeah,
I'll
yep,
have to give a quick shout out. Ooh, it looks like it's automatically scrolling here. um, but I'll have
yeah,
to give a shout out to whichever website we just got to get this beautiful picture. It looks like it's Trenner HL. I believe these are the architects on the project.
awesome.
Yeah.
Awesome. Yeah. Yep. So that's the final product. And it was great to be part of that, to just check all the important structural components of that project. Lots of concrete went down on it too. And yeah, now they're able to serve their clients better and allow for more people to have surgeries and whatnot. So
Yeah, it's really something to see the completed structure and then to come back to, our article that we wrote with this picture on it and see just when it was just a set of beams and soil.
yeah. Yep.
So, okay, well, I'm going to close out of our screen share because I think we're drawing closer to the part I'm most excited about in this live stream today, Dru. It is time for the demonstration, the special demonstration you have planned for us, and then also a tour of the lab.
Okay. Yeah, for sure. Yeah. So we're gonna break a cylinder. And yeah, pretty exciting. So let me take my camera off the tripod here.
Okay, and can you still talk to us while you're doing that?
Yeah, I tried to find someone that could be the camera guy, but I don't think I was successful. So that's okay.
That's okay. Everyone's busy, right?
Yeah. So I'm gonna flip my camera around, but I'll talk you guys through it.
Okay.
So yeah, here we go. Whoop. Camera.
Awesome.
Okay, yeah. So this is just one example of a cylinder that we cast in the field. It's been curing for 28 days, and this is for the project for Maverick. And so the first thing that we do is we measure at midpoint there what the average diameter is, and then of course through math and relationships we can figure out the cross-sectional area of that, and we write it down on our sheet here, and then we go ahead and weigh it. That lets us know how dense the concrete is.
Hey, Dru.
And the more dense the concrete in general, the stronger it is.
Hey, Dru. I think at a point you might be holding close to the microphone, perhaps. It just kind of muffled your voice a little bit.
Oh, yep. Actually, I do have a camera woman here. So. Okay. Yes. Okay. Can you repeat that, Marissa? What, you couldn't quite hear that?
Yeah, it was a little tough to hear you for a second.
Oh, okay. I must have covered the microphone. Yeah. So what I was saying is we weigh the cylinder, and so to check the density, if we know the cross-sectional area and we know that this is an 8-inch length cylinder, we're able to find the density, and the more dense the soil is, the more dense the concrete cylinder is, typically the higher strength we see.
Okay, and so you got a camera helper?
I do. Yep.
That's awesome. Thank you, whoever's behind that camera. Whoever's holding it, if you could just be a little mindful of where your hand is. I think the microphone might still be muffled just a little bit.
Okay, cool. Yeah, shout out to Danielle.
Okay. Thanks, Danielle.
So we're gonna flip the machine on here. Make sure that's all clear. We put it on these protection pads just to give it a nice solid contact. And we'll stick it in here. Marissa, can you hear me over the churn of the machine?
Yep, we can hear you.
Okay, awesome. So yeah, we'll zero it out. Make sure it's good to go. And then we're going to bring that down until it makes a full connection. Once we ensure it's a good connection, we're going to go ahead and close this for the safety of all of us in this room. On that. So this right here tells us what our load rate is, and then this is our total load. If you can see that, it's at 14,000 pounds right now. We don't want to get it. We want to keep it within a range. Over here, it's called a feed rate. We want to keep it below 527 and above 351. So you can see that. So yeah, as you can see, we're building strength. We're about to 30,000 pounds, and we'll hear a crack here, and then I'll show you guys the results of the break when we're done here. So yeah, it's already starting to fluctuate. The numbers are already starting to fluctuate. It's starting to the concrete is starting to be stressed. We're at 47,000 pounds right now.
Wow.
And we're loading it at about 500 pounds per second.
My
which is
goodness.
crazy.
And when don't you need to get out of there?
6,000 pounds. So it cracked just a little bit, but that doesn't mean that it's compromised. We go till until the entire cylinder is compromised. We're now at 62. There it went. So we went to about 62,000 pounds. We're gonna make sure it's fully broke. So it cracked pretty good there, but we'll break it. We'll make sure it's fully broke. It might get just a little bit more straight. Okay. You can come over here. Get ready. It's gonna be another loud pop. Woo! Okay, that's broke. So all right, so we'll go ahead and retract that if you want to show them this. So that's broke initially, and I'll pull this out here. It broke kind of on the edge there, so that would be a type 5 break. But yeah, that's the demonstration.
Wow. Well, thank you, camera woman Danielle. And gosh, thank you, Dru. That's so interesting. You can definitely hear it pop. I was worried about you in there. You said you had to back up, right?
Okay. Hold up. Can you repeat that, Marissa?
Sure. I was just saying thanks to Danielle and to you for that demonstration and for filming it. And I was also saying it was really cool to hear it pop. And I was worried about you in there because didn't you say you had to back up?
A little bit, yeah, but we have a good cover here.
Oh, okay. And why do you need to back up? Is it just because the concrete might come flying out?
Yeah, So let me flip the camera just one more time here. So you can see that 65,000 pounds was the break, which is actually pretty impressive that it was exactly 65,000 pounds. But if you do the math, roughly 65,000 pounds is about, if I had to guess, it's like 5,400. I don't know, we could do the math pretty easily.
Yeah, tell me how to do it. I'll pull up my calculator right now.
Well, we had an average diameter of so we had an average diameter of 4.01, 0.001. So that would give us, let's see, give me a second. We have this fun little cheat sheet chart that we can use just to check real quick. Okay. Yeah, so 4.001. So what you need to do, Marissa, is you need to take 65,000 and divide it by 12.573.
Okay, I'm on it. Hang on.
Yep.
65,000 divided by 12.573. We've got 5,169.8.
Yeah. Yeah, so 5,100 psi. That's a lot of strength. The spec is 4,500. So this and the specification goes off of a 28-day strength. So by 7 days, it should have gained about 70% of its strength, and then over the next 21 days, it should gain to 95 to 98% of its full strength. And something interesting that probably a lot of people don't know is concrete's, in theory, always gaining strength. It's always gaining strength a little bit because it's still curing over its entire life. Now we know practically when concrete cracks, like a sidewalk cracks or something, obviously it's compromised at that point and not able to hold any more strength. But yeah, so 28 days strength is the spec. It was 4,500, and we just saw that cylinder passed at 5,100 psi. So it's a good test.
Wow, that is so interesting that concrete is gaining strength. I didn't know that, Dru. That's really cool. We actually just got a comment in from our colleague Chase. He says, hypothetically, if the same cylinder were to fail, would the client then have to rip out all of the concrete in that batch or pour and start over at a new 28-day cycle?
That's a really good question, and I'm glad that he specified hypothetically because yeah, that could be big issues. But what we do is we typically cast 4 cylinders, okay, and one is to break on 7 days just to have an idea of strength, to see if they can remove shoring or something, for temporary strength. And then we do 2 28 days. So I'll do another one after this live stream, and we'll take the average of them. Okay. Now, if the average of them both fail, then it doesn't meet specification. However, we have a 4th one. Okay. We've tested 3. We have a 4th one, and we save that for 56 days. Okay. Most the concrete, it is, by the time stuff's built on it, it's already 56 days old, right? Although Maverick, I'm not sure, they built like the whole thing in 56 days. But anyways, if the 56-day fails, that is when you could see yeah, that's when you could see concrete businesses suppliers going out of business because they lost so much money because it all has to be ripped out, and it'll be ripped out by the contractor. But um, if if they didn't add too much water and it was the concrete supplier's fault, the concrete supplier is liable for all that time and money of pulling it out. Now, again, Chase said hypothetically, and it's true. In my 4 years, never seen it happen. Um, yeah, never. The concrete industry has things down. Now, I would say I did have a 28-day fail one time, but it was because they ordered the wrong concrete for the specification, but it still passed 56 day. So
Wow, that is so interesting. You're right. It does seem so precise. This has to be one of my favorite live streams, Drew. This is so much fun. And it's just cool to see the live demonstration and see this lab. And this lab is right in Coffey's headquarters, right? Like you're just downstairs in the same building as Dave and Danielle and everybody, right?
yep. The lab's just it's a modified garage, but it gets the job done for sure.
That's really cool, Drew. So can you show us around a little bit more?
Yeah, I can. Let's see. Let me change the camera to the back here. But yeah, so I guess we'll kind of just start over here. This is a glorified horse tank. I mean, it is a horse tank, but it's glorified because we have a heater to make sure that the temperature stays within the specification of which our cylinders cure. So, and then we have a nice insulated lid to keep the heat in. And then some of these over here is our hand sieve shakers that we use for gradations. This is a pile of dirt that or soil to be technically correct, a pile of soil that will have a gradation done. And when I say gradation, that's essentially seeing how much weight is on these sieves. And so if you can see that there's a bunch of different sizes. So that's a 1 inch, but something like this is 3/4, and then we go down to like a 3/8. And so yeah, this is a splitter for we take the soil samples and we split them among 2 bins here, just to make sure that we have an accurate sample, that it fully represents all the percentages of rock, sand, and clay and silt. This is our Proctor mold, where we will run Proctors, and I'll show you what that mold looks like real quick.
Cool, yeah, because you were talking about Proctors earlier, so it's nice to see the real thing.
Yeah, can you repeat that, Marissa?
I was just saying, I'm glad you're showing us the Proctor tool because you were talking about Proctor earlier, and so it's nice to see what exactly goes into it.
Yeah. So yeah, essentially, this is the Proctor mold, and we know the volume of the mold, and so once we capture the weight and whatnot, then we know what the density of the soil is, and we have to do it on this concrete block because we drop essentially 5 pounds 12 inches multiple times, and it's a pretty big impact.
Wow.
So yep, so then we have our oven to dry out samples. Almost anything we do in the lab, all samples have to be dried completely before we work with them. It's just part of the American material testing standards.
Sure.
And then, yeah, just your classic scale here. I guess I'll come to the other side here. Of course, the cylinder breaker in all its glory. And then we have our nuclear density gauges, and our other asphalt tester. I'll just show you guys real quick.
Yeah.
What
And
this guy looks like.
And once you're done with the tour, Dru, I'd actually love to talk about that nuclear density gauge pretty quickly. And I know that we just, made a cool new purchase. So it'd be great to just talk about that.
Yeah, I would be happy to. So some of you guys who might be tuning in or watching this video are going to be expecting me to pull out a yellow gauge. But we're rocking a white gauge now. And so let me pull this out for a sec.
They didn't have green, Dru?
Okay. Let's see here.
Can you hear me, Dru?
Yes, I can. Sorry.
I said they didn't have green. They didn't have coffee green color.
No, they didn't. So yeah, this newer gauge is pretty cool. So I'll just show you real quick. I'll show you what it is, and then we'll talk about it. So this is the gauge and what it looks like, and this right here is a rod that goes down into the ground. Okay, and then this is what's called a moisture probe, and so as I talk about that, what's really cool about that particular nuclear density gauge is it doesn't require licensure. And the reason all the other gauges require licensure is because they have a radiation source. And from a I mean, they're called a nuclear density gauge. So they have a source that's decaying, and it has very minor effects on people's health. They have warnings that women who are pregnant should not operate a nuclear density gauge. Now, so this is really important because we have purchased. We are now a license-free lab. That switching from a yellow gauge to a white gauge allows us to be license free, which means it's a smaller source of radiation. I mean, really hardly anything, and doesn't have. It has almost zero effects, health effects, which is better for our employees and better for the work environment. And so, not to mention all that, but it's about $4,000 a year to keep up with licensure. Paying me for all the upkeep and then paying our license itself. And so, yeah, just super. I mean, it is the future of nuclear density testing, and now we are license free, which is really exciting.
So, Dru, can you explain that just a little bit more? When you're saying license-free lab and then the $4,000 a year to keep up with the licensing, is that to operate the nuclear density gauge, or is it a larger license for other things?
It's only to use the nuclear gauge.
Wow. Okay.
Yeah.
Got it.
Yep. And so there's tons of stringent requirements that we are not held to anymore because we don't have a health anything that can harm anyone's health anymore, which is really nice. And I've tested them in the field for about 2 weeks, and they've definitely stood up to the bar and are as accurate or more accurate when it comes to densities.
Wow. So that's really interesting that, I just love this about Coffey, is that we continue to look at the newest equipment that's out there and continually look for ways to improve. Even though we're a 70-year-old company, 70-year-old company, we don't just, stay in a habit of operating in a certain way. I really think part of it has to do with our sense of continuous wonder and wanting to learn how to do things better. That makes Coffey dynamic and just a great partner to use. I also think that this is case in point, the nuclear density gauge, getting the new one. I mean, this could potentially also be a little bit of a savings for the client, since over time it's costing us less to hold certain equipment or licensure for that equipment. But then also just to know that, there's a safety in the product too. That's really nice.
Yeah. Yep. Absolutely.
That's really cool. So it's really interesting to know, of kind of equipment that Coffey does. It's a little different than other people, or maybe they'll eventually catch on to this piece of equipment. But just that it's a pretty new piece of equipment, right? We're pretty quick to get it.
Yeah. Yeah. If there is any material testing companies that are watching this, I mean, yeah, we have an edge on you, but I will tell you this, that it's worth it. I mean, I did the general, financial calculations, and we're gonna have all the two new gauges that are non-licensed paid off in less than 5 years. If you look at it from a financial standpoint, because we're not paying me to keep up with licensure anymore, and we're not paying for a license. So, I mean, if you can be license free in 5 years, I'd say that's a win. We could pay it off as early as 3 years.
Wow. That's really cool, Dru. Oh, it looks like we have a comment from Julia Ribeiro. Hi, Julia. Thanks for tuning in. She says, wow, I'm proud to hear Coffey switch to a less harming nuclear gauge. Thanks, Julia. Yeah, we feel that way too. That's really a cool thing to be on top of different ways to make our careers more safe. This is definitely an industry in which human life is at a little more risk than other industries. So, more and more ways that we can stand up to that plate and ensure the safety of our employees, and our projects is a huge priority for us.
Absolutely.
So we've been answering a lot of the questions as they've been coming in, Dru. I don't think we have any more from anybody else yet, but I have some more for you. If you have another couple minutes, we are about 2 minutes away from ending the live stream anyways, but we might just stay on another 5 if that's all right with you.
Yeah, I got some time.
Okay, cool. So this is a question that might be obvious. The answer might be obvious for some viewers, but less obvious for others. Since we went into the demonstration of the concrete cylinder compression test, I have to ask, can you sort of give us the beginning and end of that concrete cylinder's life cycle and how it applies to the job? Like, is this a piece of concrete pulled from the job site, or is this a piece of concrete that was made by the concrete manufacturer for the job site and then it comes to you before it even sees the job site? And then what happens? It gets installed when you approve it. Kind of how does the whole process work?
Yeah, that's good. Just a second.
Okay.
So this is this right here is a cylinder that was just casted, and so how that, and it's obviously cured and hard, but essentially what starts is we're notified there's a concrete pour, and we check, we take a sample from the concrete truck, put it in a wheelbarrow. In fact, yeah, the wheelbarrow's right behind me. You can't quite see it, but we get in a wheelbarrow, and then we check the temperature, we check the air content, and the slump. And the slump tells us the workability of the concrete, and also tells us a little bit about the water content. And so we do those different tests. And then after we do those and they pass the specs, slumps usually anywhere from 3 inches to 7 inches, and then air content, if it's outside, it needs to at least have 4.5%. We wouldn't want more than 8 because then you start to compromise the strength. But as you after that's all passed, then yeah, as I showed you, this cylinder mold, it starts empty. We take and through a standard procedure, we fill up the concrete and rot it and tap all the gaps out of it, and then we let it cure for a day. Take it back to our office like we have with this one, and then we take and strip the molds and put it in our tank and wait for the 7-day and 28 days test the strength.
Wow. Okay. So, and when you say you're notified that there's a concrete pour, does that mean like it's actually going down at the project site and you're there at the project site grabbing the concrete, or what exactly, when do you intercept it?
Yeah, we at the pour, we get I like to get about a minimum of 2 yards out of the concrete truck, and then you know, they'll put it wherever it's going, whether it's a sidewalk or whatever, and then we pause it, and yeah, we intercept the concrete right there, and pull our tests and cylinders.
Okay. So that's pretty interesting. Normally, I would have just responded by saying that's kind of risky that they put the pour down and then you're testing it right from there as they're still pouring, because what if it doesn't work, right? But of course, they don't, release the project to the public that day or anything. But really, why I'm no longer concerned about that question is because of how reliable you've been saying all of the concrete pours and testings have been in your lab. Just how how Chase had said, hypothetically, if the cylinder failed, what would then happen? And you had said it really doesn't fail much, that concrete really is a science that's pretty well down.
Yeah, absolutely.
That's cool, Dru. So 1 or 2 more questions for you. What do you see the most of in the lab these days? And has that changed recently over time? Or have you pretty much been doing, has your most common job remained your most common job over the last, year, would you say?
I had trouble hearing you a little bit there. Could you repeat that? Sorry.
No problem. Sure. So I'm just wondering, what do you see most of in the lab? Like, what do you work on? What's the project or the test that you do most in the lab? Are you most of the time doing concrete cylinder compression tests, or are you?
Yeah. The most common thing that I do in the lab is proctors. I mean, yeah, we probably pound out 40 to 60 proctors in a summer, for different project needs. Just because if the soil material changes, we're going to run a proctor. That's something that I think we do well compared to our competitors. Is we'll take multiple proctors because material does change quite a bit, and the contractor or the client, the construction crew, whoever may be doing the correct method of compaction and doing a good job, but if the material changes, then the density changes, and if the density changes, we're gonna have bad compaction results for our numbers with our Newt gauge. So yeah, we pound out a lot of proctors because if the material changes, it's not the contractor's fault. It's our job to identify that and get another proctor in the process so that we can get better. We can get better results with the nuclear density gauge.
Okay, I see. And then a final question is, I know that, we're headquartered here in Laramie, Wyoming, and then we also have an office in Loveland, Colorado. But I know that a lot of our projects span across many states. And I'm just curious, with materials testing, do you see projects in other states as well? Or how far could we provide services to? Are we just providing services with materials testing in Wyoming and Colorado, or do we provide service to a larger area?
Yeah, that's a really good question, and it's fresh on my mind. I would love to see Coffey take material testing to the next level, and the next level is doing longer distance projects. Right now, we do projects as far as Casper, Lusk area, so about 2.5 hours, and we've done some projects in Colorado as well. We have an office in Loveland, so one of our focuses is going to get a material testing lab going there, so that we can at least be getting those projects more southern Colorado, because there's tons of construction there. And then the other thing is, when we get further than 4 or 5 hours, it's quite a journey for someone to come back, to wherever, if home's in Laramie, and so Dave and I were talking a little bit about that this morning, and I've thought a lot about it. What are the logistics of sending someone to a job, to do testing? We're going to have a temporary or portable lab that can pretty much go wherever, and I'm working on that, on some of the concepts of that right now. But the more logistics is, okay, you've got a lab for someone, but having them, having someone committed to a job for a month, staying in a place that's not necessarily their home, it is challenging. I mean, ideally you find someone that lives in the area of the project, but then you're just doing temporary hires. So it's that balance between temporary hires and permanent hires that and still make them excited to come to work and stuff like that. So
Absolutely. Well, that's really cool. Thanks for giving us some insight into, the conversations you're having with our CEO, Dave. And just, again, for me, it shows me, again, that adaptability, that dynamicism of Coffey to change and mold with the needs of the clients, and just, again, always taking a fresh look at what we can do better and what we can provide people with. So, I think that that's another testament to the office, that, the expansion into Loveland, Colorado, and now having the breadth of our services out there. And the traveling is certainly an interesting subject. I mean, yesterday I talked to you and you were in a hotel, so you clearly had to do some work somewhere away from home. So it's definitely worthwhile then, would you say, for a client to reach out if they are outside of Wyoming and Colorado to see, what they can arrange with Coffey in terms of materials testing?
Yeah, absolutely. Yeah, anyone to reach out outside of Wyoming, we can put some numbers together and see how we can make it happen. Absolutely.
Awesome. Well, Dru, that was all of my questions for you today. Do you have anything else to add?
I don't think so. That's that is our material testing program in a wrap, and a great tour of our lab. Just really excited to see where we're going next. This Lusk project has been one of the bigger projects that we've been able to just lock down and work on, and it's brought new possibilities to Coffey, and So we're really excited about that. The cool thing about the LESS project is there's multiple phases, and each phase is about a year and a half long. So really big projects, and it's really exciting. I'm excited to see how much staff we can bring on material testing. I'm also excited to get the lab going in Colorado.
Awesome. Well, thank you so much for your time today, Dru. Thank you for one of the more exciting live streams. It's just been really fun to see a different view on the other side of the camera, to see the inner workings of a lab, and to also see a demonstration and to hear a concrete cylinder pop. It's definitely been a pleasure. So thank you for your time, Dru, and we'll talk to you soon.
Yeah, thank you so much, Marissa. I'm glad we were able to do this. Really exciting.
Yes, me too. All right, well, you have a good day.
You too.
All right, bye.
See ya.